So India is one among them. So let me give you one more point that India ranks even first in the world in terms of fatal landslides. So you can see how India is getting impacted from the number of landslides that are happening all over the areas. So due to this location thing, and we have also various other causes of the natural disasters that are occurring in our country today. We will be dealing about India, of course. So we will be focusing more about the causes and impact of natural disasters, specifically landslides. If I'll say about floods and landslides, these are one of the major disasters, obviously mostly occurring in Himalayas and Western Ghats in India, since these are the two regions where we have steep mountains and steep slopes. The number of landslides are more in Himalayas, but from last 2 3 years, it has been more in Western Ghats also. Just to give you an example, I'll give you some examples like Kedarnath disaster happened in 2013. That was example of a huge debris slide sweeping away the whole Rambara village of Kedarnath. So that was huge disaster that happened in 2013. And similarly, Kerala flood happened in 2018. Recently, 2 years back, you might have been aware of this flood and landslide, and that was also a massive one. So for these 2 years, we have accounted more than 2,000 landslides in one particular area. Like, for example, Western Ghats or Himalayas, we have detected around 2,000 of landslides, including small and large ones. This is also a brief idea about the GIS and maps, how it is being monitored in disaster management activities. So we have preparedness, where we are talking about resource inventory, logistic planning, communication, and so on. And we have discoveries and rehabilitation activities. We have prevention, mitigation activities. We have relief, we have response, and we have prediction and warning. All those things are there. You can see this slide, and if you have any query related to this slide, you can type in chat box, since we have only a limited time of 1 hour during this webinar. So we cannot go in depth in every related field. So I will just come down to our important topics. So if you have any questions, any regardings, we can keep it for the question and answers round. So now coming to our debris flow and its types. So what is debris? So debris is a mixture of sediment particles. It can be of varying sizes and strength. Mainly debris is composed of some rocks, mud, and water. It actually happens when there is a unprecedented rainfall in that particular area. So rainfall gets infiltrated, or it percepts down the soil. It makes the soil weakened, and the soil with all the mud, water, rocks, it slides down, and it can move in a very high velocity and can damage property and people a lot. So and due to their capacity to travel long distances at a very high velocity, the threats to human life and property from debris flow is much higher than any other landslides. What are other types of landslides apart from debris flow? We have rock fall, we have slides, we have creep. So these are the four types of major landslides. But today in our topic, we are dealing with the debris flow. So in this debris flow, that is the primary cause that I have already told you is unprecedented rainfall and earthquake. So in some of the scenarios in Uttarakhand, like Chamoli is a region where debris flow occurred due to the earthquake. The reason was earthquake. So the two reasons can be the major cause of this debris flow. So is one among the type of landslides according to the Vaughan's classification. So if you want to get into detail about the landslides and types, then you can refer this paper, Cruden and Vaughan, that is of 1996. It gives you a detailed overview about the type of landslides, about the type of disaster activities, and what is debris flow, how it is different from other type of landslides. This is very important topic if you are if you want to work in the natural disaster type of activities, and so you can refer this paper. So this is again the phenomena. As you can see, there is unprecedented rainfall in the imagery image, and then debris is falling from the slope to the downward areas. So in this way, debris occurred along the slope or along the type of hilly terrains that we usually see along Western Ghats or Himalayas, whether even in northeastern Himalayas, and so on. So, what kind of debris flow we monitor? We have mud flow. That is the most common type of debris flow that we see in Kerala, down south or north. For example, in Uttarakhand, Himachal Pradesh, we generally monitor mud flow. We have then Leher, that is volcanic debris flow, when the volcano erupts and the debris that comes out of the volcano, that is called leher. And then we have a till flow, or we can say avalanche flow, when the debris come out from the stagnant ice, or that ice that we have, and then it suddenly breaks down or it melts, snow melts. So in that case, so recently in February 2021, this uh, a flash flood came in Uttarakhand, so around Chamoli region. So that was also one of the avalanche flow, and so many people died in that disaster, and it was a huge one in terms of injuries, in terms of properties and people. So these are the type of debris flow that we usually see and analyze. So now you can see this debris flow imagery that I have taken it from the Google Earth, and you can also see after finishing this session, you can go on to Google Earth and you can explore the places where all these kind of landslides have happened. So this is of Kerala floods 2018, recently 2 years back, which the floods came and it was a huge one. So 6,970 landslides comprising of 22.6 square kilometer areas were mapped. So this landslide we only mapped, ISRO mapped, and we have also published one paper. So you can also go through this in Google. So you can see the pre-data, pre-disaster. There are no scars. There are no symptoms like anything is going to happen in that particular area. But post disaster, you can see this is a Kuchilmala landslide in the Wayanad region of Kerala, and it was a huge landslide. And more of the houses, I think 4 or 5 houses were there on the downslope, and all those houses got damaged. So you can see even the flow is unchannelized. That means it is going in 3 4 directions. So this is one of the major landslides. Then majority of landslides that occurred in Kerala is 5191, and landslides were mostly debris sliding and debris flow, and entrainment along the channels. Entrainment means it along the channel also it carries the mud and sand and water content or rock with them, even the downslope also. So this is one of the major landslides. In 2019 also, Puthumala landslide happened, and even recently also Pettimori landslide happened. So nowadays Western Ghat have also become prone to major type of landslides. So I should also say, because this landslides happen due to the unprecedented rainfall from 19th August onwards. On the 19th August, 20th August till 21st August, and even pre-monsoon also from June onwards, I should say, the rainfall started in this region, and it went for 2400 millimeter of rainfall was recorded, and expected was 1600 millimeter of rainfall. So you can see the difference, expectations versus reality. So expectation was 1600 mm while it was 2400 mm between July to August 2018. So it was around 42% above normal rainfall was there, which led to these kind of disasters. So now coming to a flow modeling type, how we will model this flow. See, we have different kind of debris flow, and there are so many debris are there which are occurring nowadays due to monsoon. So complete prediction of the occurrence is not that feasible because it's a bit complex process. But the flow path or the propagation of the material, like how much the material will flow from top to bottom, and how what are the behavioral parameters that could be estimated in the flow modeling. So this is also an important thing, though we are not predicting, but we are predicting the flow, till what extent it will flow, and accordingly we can take the rescue, we can do the rescue or mitigation operations accordingly. So now it is possible to perform a forward analysis and predict the changes in future. But as I have told you, like it's a bit complex process, so we are not going into that. But in future, definitely we will be predicting on the locations where the landslides or these disasters are going to happen. But as of now, we are doing the back analysis. Back analysis in the sense the disaster has happened, and we are modeling that thing. And in near future, in the same area, if some or the other similar debris flow happens, so we can monitor and we can analyze, we can interpret the path that it is going to travel, and we can help society as a whole. We have certain parameters that you will be analyzing, whether we will be taking some ground reference parameter. For example, we have soil sample, we have rock samples. You can go on the ground, and we can collect those things, we can analyze in the laboratory, and we can do such analysis. But going to ground also, it's a bit cumbersome sometimes. So how we can do all those interpretations and analysis using the GIS and remote sensing software, that I'll show you. So for that, we have two models. We have statistical model and we have dynamic models. So statistical model is, as I have told you, it's a bit more oriented towards the ground data, where we go to the field, we collect data. But some of the situations and some of the point, it is critical to go there, For example, if continuous raining is happening, so it's not possible for us to go in that particular field or that particular area, since it has been raining continuously. Or if the debris has happened on the steep slope, for example Himalayas, so climbing Himalayas in such steep terrains, it's not possible. Dynamic models comes into play. So dynamic models are basically based on the physical model, on the basis of fluid mechanics, on the basis of mass, momentum, and energy. And due to these equations, algorithms, we can monitor the type of flow and where it will follow, what will be the height or what will be the pressure and momentum of the flow. So because of this reason, dynamic modeling has become an increasingly important phenomenon nowadays for simulating and analyzing the characteristics and behavior of the debris flow for the physical laws of conservations of mass, momentum, and energy, and so on. So, due to these dynamic modeling techniques, we are able to monitor the flow or the debris, the kind of hazard that has happened while sitting at our own place and analyzing those results. So now these are some of the flow model dynamic flows that we generally do. We have mud flow, we have ramps, we have Dan 3D, mass move 2D, flow 2D, Titan. We have different type of softwares that are dealing with the flow phenomenon, and these are depending on the rheology, solution approach, reference frame, and these are the differences between one model to the another model. So these models are basically dependent on the equations, rheological equation. Rheology is nothing but the continuum of the friction or any volume equations that these algorithms are based upon. What are the behavior of the flow? According to the behavior of the flow, equations are being determined. And then we have a solution approach like continuum integrated. Integrated means everything is integrated. For example, if a debris flow, as I have told you, it is a mixture of rock, sand, mud, water. So when everything gets mixed up, so discrimination becomes very difficult. Like you cannot discriminate between the particle, that this is rock, this is mud, this is water, and so on. So that is continuum integrated. And we have a reference frame. It can be Lagrangian. So it is the type of the data or the display that we want to see. So Eulerian is type of a fixed mesh. It treat particles as a continuous thing, and while Lagrangian is meshless sometimes, and it treats as a discrete phase and tracks the pathway of each particular material that is flowing from top to bottom. Now, this can be an important slide for you. This is a commercial and open source tools for flow modeling. So we have commercial like RAMS, Flow 2D Pro, DanW, but we also have open source tools. So for example, if you are a student and you want to do some training or for some research, for some project, you can use this open source tools. It is now freely available, and sometimes it is based on Windows or Linux or Ubuntu and so on, depending on the type of tools. That is debris flow predictor. Debris flow predictor is also an open source, and it's very good software. Actually, I have personally used it, and it is from the Stanford University, and you can contact to those people. You can write it down that you want this software, and they can give it to you. Then Titan 2D, Mass Move 2D, and our flow. Our flow also, I personally used it, and it is also one of the best software for modeling debris flow. It is also freely available. It works on Ubuntu. So the codes are easily available, and even the guidelines are also available. So if you want to personally use it, so you can go through the manual of this softwares, and you can easily install it in your systems, and you can start doing your debris flow modeling as an activity. So now, what are the software requirements? We should have DEM. For example, it can be of any resolution, like if 30 meter or 20 meters, anything is available, so you can download it, and you can have release area. So release area means the area from where the landslide started occurring, or we can say it is a zone of failure, from which zone the landslide has started occurring. So from where will you get the release area? So you can get the release area from the Google Earth imagery. So as I have already shown you one of the image, in that particular image you can find out from where the source is actually occurring, and you can delineate as your research area, release area. So now we have depth information. So depth information is also, it is if you're going to a ground, if you're taking ground observations, then well and good, but if you don't have any ground validations, then this depth information is basically when you see a landslide, when small landslide happens, so the depth will be obviously less, and if a very large landslide has happened, so in that case the depth will be much more. It can reach up to 10 meters or 11 meters also. So like this you can do trial and error sometimes, and you can see what kind of depth information you want to give on that particular landslides. Then we have flow shapefile. This shapefile will be your landslide shapefile. This is going to be there for the validation purpose, since you have modeled the flow. After modeling you can do validation. You can see your simulation results, how well it is coordinated with the actual flow. So actual flow, how you can see? By creating a shapefile. Again, you can see that in the Google Earth. So, why open source? We are working in some industry, but still, we also prefer open source sometimes, and because it is convenient, it is easily accessible, it is mostly recommended, and it has acceptable results. So, first of all, every student or every industry cannot afford commercial software since it is paid, but nowadays we have options of open source tool also, which are very easily accessible, and you can see the code how it is working. You can install it in your systems, and you can uh, start doing a type of research or the application areas wherever you are currently associated with, and the results are also acceptable, and the results are also satisfactorily good comparative to the commercialized software. So I prefer open source from a commercial point of view. So if anybody wants to work upon it, they can easily do that. So, working on this flow model tool, I have given one case scenario where I have utilized the RAM software, that is Rapid Mass Movement software. It is basically developed by WSL Institute for Snow and Avalanche research. This is based on the dynamic volume based equation, this rapid mass movement software, and it comes into three domains, that is avalanche, debris flow, and rockfall. So the parameters that we will be giving, as I've already told you, release area. We can give a release area. Sometimes landslides occur from multiple release areas, not only from one particular zone of initiation. So we have 2 to 3 kinds of zones of initiation. So we take all those 2 to 3 zones of initiation, and we use a two parameter volume equation to describe the frictional flow. So as you can see in the picture, we have a source area from where the landslide happened, entrainment mass, what kind of material it is taking with it, and then we have a deposits, that is a deposition source where the landslide has actually stopped, and how much is the deposition area. And on the x and y axis, as you can see, the height, from how much height the zone of failure has occurred, and run out distance, how much kilometers or how much meters the landslide has actually flown. So this will be your run out distance. Now coming to the boundary equation, it takes into account flow density, gravitational acceleration. It depends on the slope angle, flow height, and flow velocity. So these are the equations that is there for the boundary conditions. We all these parameters are integrated, and then volume based equation is being produced for this particular software. Now these are the results. What we are getting in results, we are getting calculation and animation of the runout distance, we are getting flow height, flow width, flow velocity, and the impact pressure. So as you can see in the picture, this landslide has happened, and we can model the path of the landslide from top to the bottom, on what, at exactly at what point the landslide has moved, what path it has followed to for this particular area. So all these things we can model through the rapid mass movement software, or commercial software, or any open source software that we are using. So like this we can see. And now for example, at the bottom, if there are some settlements or there are some houses, so next time if similar incident happens on the same terrain, so we can ask them to clear this area, as this area is will be subsequently disastrous for residing. So now for validation using remote sensing, if we have got the flow path, we have got so that flow path, how you will see that it is correct or not. So we have to validate those paths with the actual landslide shapefile that has happened. So you will correlate that shapefile, landslide shapefile, with the simulated flow, and you can see if the area is matching or not. And you can also export your results to Google Earth or ArcGIS or other tools, and then it can be fed into GIS environment for further analysis. In further analysis, you can calculate the area, you can take the overlapping area, you can do various analysis on that particular flow model, and you can see how the area is getting affected, and how some similar kind of events if are happening on that particular uh, terrain. So now risk mitigation, obviously we have seen all those things, how what are debris flow, what are landslides, and how it is actually impacting the society. So these are the risk mitigations techniques that we can use using debris flow modeling. So the results that will be produced will be of great benefit for the disaster management activities, will be helpful in understanding basically the flow dynamics, and which can help in disaster management and response activities. It also predicts the flow path and all the risk that is associated with the debris flow modeling, that is very beneficial for the society as a whole, and for all the preparedness for mitigation activities and so on. In this way, at least we can control the flow path, we can control the debris flow that are occurring all over in India, and it has and whole India is prone to disasters like this. So at least through our efforts we are helping mitigating the risk and all the factors that are created or impacted due to debris flow modeling. So for the disaster related activities it is of utmost importance. So these are all the references I have put. We have put our paper also on the sixth number that you can see. We have done research and we have mapped landslides for the 2018 disaster. We have all other major references that I have included in the paper. You can go through it, and if you have any doubts, you can let us know, or let us know the Skill-Lync people associated with it, so that we can help you out in any way we can.